Okay, eat, sleep, revise, repeat. This is the Unit 1, so it's C1, Chemistry 1, higher tier. If you've just sat your mock, it was a real paper from March 2012. Good luck. Let's see what we've got. So, open the paper up. You'll see the first page, periodic table. Don't need it really at C1, I doubt. Then you've got a blank page. Easy so far, pretty good. Right, fractional distillation. Let's just have a look. Right, the answer is going to be C. So, molecules of diesel oil are longer than molecules in petrol. So, which of the following is true? So, put a cross in the box next to your answer. Fuel oil has a lower boiling point. Okay, so the lowest boiling points are at the top. So that was wrong. Kerosene is more viscous. So if we've got the high boiling points at the bottom and viscosity increases as we go down, so the most viscous things are at the bottom, that's the most stickiest things, or the stickiest things. Diesel oil is easier to ignite than petrol. Well, easier to ignite, there's diesel oil. No, easier to ignite is at the top because volatility increases as you get to the top, so that's easy to ignite. Okay, so the answer is molecules in diesel are longer, so longer molecules as we go down. Okay, so molecule size increases as we go down. Okay, volatility increases as we go up, more volatile. Viscous increases, viscosity the more sticky down at the bottom. Tough one that for 1 mark, but there we go. Right, can only get easier. Some fractions obtained from crude oil are cracked. Okay, so what does cracking mean? What's large molecules are made into smaller ones. Okay, that would get you the 2 marks. A bit of extra information there is that the large molecules are in less demand, so smaller ones like petrol, you might crack some paraffin to make some petrol, which is you don't get enough of that from fractional distillation, which is the process up there. Okay, that's fractional distillation, just separates the crude oil by its boiling points. That's a physical process, separating by boiling points. But this one here, cracking, is a chemical process. You actually take the large molecules and you crack them. You make them smaller to more useful molecules. Okay, gosh, tough paper, eh? Right. Okay, so we've got right. What is meant by unsaturated hydrocarbon? Okay, so unsaturated means it has double bonds. So it's a double bonded molecule made of hydrogen and carbon. Okay, so 2 marks, one for saying what it's made of. Oh, sorry, carbon, hydrogen, and for saying it's got a double bond. Okay, so if it was saturated, that's what it just has single bonds. Okay, and you would need another hydrogen then, because each carbon's got to have 4, and that would then be called ethane, instead of what it was ethene with a double bond, ethene, and that's unsaturated. Saturated alkanes. Gosh, describe what you would see when a sample of ethene is shaken with water. So an ethene would, okay, now bromine water is orange, so it would decolorize, is that the word? Decolorize the orange bromine water. Okay, so it decolorized the orange bromine water, but it's 2 marks, so it would decolorize bromine water, so it would go orange to colorless. Okay, that's for an alkene. If it was an alkane, alkane stays the same. Okay, alkane stays the same, so it wouldn't decolorize it from orange to colorless, it would stay orange. But with alkenes, okay, they change colour. Gosh, 8 marks for that. This is pretty tough so far. Let's see question 2. Blank page, easiest bit of the exam. Question 2. Let's have a look. Right. Okay. So percentages of some of the gases. Right. We're onto the atmosphere now. Easy peasy. State how the oceans were formed. Okay. So it's condensing water vapour. Okay. Condensing water vapour. So the water vapour in the air, in the atmosphere, has condensed. So as the Earth cooled, it condensed into liquid. Okay. How the formation of the oceans caused this reduction in carbon dioxide. Okay. So the carbon dioxide dissolve into the oceans. Okay, 1 mark. The amount of oxygen in today's atmosphere is much higher. Describe the process that has caused this increase. Okay, photosynthesis absorbs carbon dioxide and releases oxygen. So releases oxygen, 1 mark, and for knowing about photosynthesis, probably a mark there as well. Absorbing CO2 means that if there's less CO2 in the atmosphere, then the amount of oxygen proportionately would come down. So there's at least 3 marks in what I've written there. You only need 2. Okay. Here we go. So next, okay, staying with question 2, and okay, so complete the sentence by putting a cross. Sorry, somebody came in the room and disturbed me then. Okay, so this is basically, so you've got air from the atmosphere in there. We know the pie chart, which shows the composition of air. You're putting it into there, and it's reacting with the copper to make copper oxide. So, okay, so only some of the air will react, obviously the oxygen. So, this is because the gas must be at room temperature. The copper expands when it's hot. The apparatus must be left. Reading the volume while the apparatus is hot is dangerous. Okay, let's read the question. At the end of the experiment, the apparatus was allowed to cool before a final reading was removed. Was recorded. So the answer to this one is C. So the gas must be at room temperature when its volume is measured. Obviously, because gases expand when they're hot, so it's going to take up more volume, which is no good. It wouldn't be a fair result. At the end of the experiment, not all of the copper had reacted. Okay, which means must have used up all the oxygen. O2 is a symbol for an oxygen molecule. Okay, so there would have been some copper left. Some of the copper is in excess. That means there's excess copper, more than enough for the oxygen to react. Okay, okay, so we're looking total out of 9 marks. Let's see if we can get these next 2 marks here. So the percentage decrease, okay, so it's gone from 32 down to 24, which is going to equal 8. So it's gone 8 over 32, which was the total, times 100, would give you a percentage increase of 25%. Okay, so 1 mark for the working out, 1 mark for the answer. Oxygen in the test tube, as well as the measuring syringe. So that's the answer we're looking at for this one. So, why the answer calculated in part 3 is higher than John expected? Well, if we just have a quick look at the syringe on the last page. Okay, so he's putting air in from this syringe. That's measured, that's to get his result. But there's already air in the test tube, which can react with the copper. Okay, so that's already in there. So that's our answer for this one. Okay, so if we say that air, or oxygen to be more specific, in the test tube also reacted. Okay, also reacted, and that gets us the 1 mark there. Okay, so now next question, question 3. Metals. Okay, aluminium and magnesium are melted together to form magnesium. Magnesium must be an alloy. Okay, so one or more metals mixed together forms an alloy. Describe how iron is extracted from its ore. Right, so for 1 mark, it's heated. There's a mark there, by the way. Looking for 2 marks here, and it's heated with carbon. Okay, so it's reduced with carbon. Next, explain how this reaction involves both oxidation and reduction. Okay, so the copper oxide, so let's put the words copper oxide loses, and you can see there it's lost oxygen and hydrogen. You can see that it gains oxygen, so that should be 2 marks, 3 marks. Okay, hydrogen gains oxygen. Okay, so there's 1 mark for each of those, and a further mark for knowing that oxidation is the loss of oxygen, whereas reduction is the gain. Okay, reduction is the gain, so therefore reduction. Okay, so reduction and hang on, rub that bit out. Shh, sorry. Yep, gaining oxygen is oxidation, clearly, and losing oxygen is reduction. Okay, 3 marks there. Next is Continuing with question 3, explain why shape memory alloys are better. Why are they better than other alloys? Okay, because if they bend or malform, then they go back to their original shape. Okay, 2 marks there. Okay, now across in the box for this one, so we're looking at C. Have atoms of different sizes in their structures. Okay, so alloys are usually stronger than pure metals. So when you've got a pure metal, okay, all the atoms are the same size. If we mix it with something else, okay, then we put atoms of different sizes in, and that makes it more difficult for the red atoms here, or red particles, to slide over each other. Okay, and because we've got different sizes in their structures. Okay, so we'll continue with this question, and in fact it's question 4. So what type of rock is limestone? Right, limestone is sedimentary. Okay, explain how the marble has formed in above the granite. Okay, so there's the marble. Okay, so limestone turns to marble with pressure and heat from the magma. Okay, so 2 marks there, 1 mark there. Marble and limestone, same formula, calcium carbonate. Okay, but one's sedimentary and one's metamorphic. So metamorphic means change shape. Explain why the rock X has larger crystals. Okay, so X cooled slowly and Y cooled quickly. Okay, continuing with question 4, and question 4 we're looking for 10 marks overall, so let's see, how do we get this 1 mark here? Calcium carbonate is heated. Okay, calcium carbonate is heated, there's the arrow, it's a thermal decomposition to form calcium oxide, and what's missing? Carbon dioxide. Okay, write the balanced symbol equation for this. Right, well, calcium oxide reacts, so calcium oxide reacts with water, H2O, to form, that means we put an arrow, because it makes calcium hydroxide. Here's a formula you'll have to remember. There's not many, but calcium hydroxide, CaOH2. Okay, 2 marks, 1 for the products there, and 1 on the other side for the reactants. Explain why calcium hydroxide, slaked lime, is spread onto the fields. We're looking for 2 marks. So for the first mark, we need to say that it is alkali, and therefore neutralizes the acidic soil, not the acidic crops. Okay, not the acidic crops. It helps the crops to grow, but we're talking about the acidic soil. There we are. Okay, so 10 marks for that. Question 4. Hopefully you did really well on that. Let's have a look at question 5, and nearly there now, just 5 and 6 to do. So question 5, part A. We're going to say copper chloride. Why is it copper chloride? Because you need to complete the sentence. Dilute hydrochloric acid reacts with copper oxide. Okay, so we've got an acid and a base, or alkali. Okay, acid and base. So acid and base make salt plus water. We know that, we've done that loads. Okay, unless there's a carbonate as the base, then you also get CO2, wouldn't you? Carbon dioxide. But here's the salt, so copper chloride, because it's copper chloride. Okay, easy. Right. Chlorine is manufactured by electrolysis. What is electrolysis? Okay, so it's the breakdown or decomposition of chemicals. How are we going to say? Let's say compounds using electricity. Compounds using electricity. There's your second mark. Okay, so second mark there, and 1 mark for that. Okay, 3 marks here. Oh, it must be a balanced symbol equation. Right, if it says balanced equation, we're looking at symbols. Oh dear. Right, so chlorine gas reacts with, so chlorine gas is Cl2. Reacts with sodium hydroxide solution. Sodium hydroxide. A few more things to remember here. To form, okay, sodium chlorate. Now hopefully it gives us the formula. There we are. NaOCl. Let's just remove that little bit there. And NaOCl, sodium chloride and water. So, and sodium chloride and water. Okay, now, so far, there's 1 mark for the left, the reactants, 1 mark for the right, the products, but we need to balance it, okay? So, it does say balanced symbol equation. It's worth 1 mark, okay? So, we've got 2 chlorines on that side, Cl2. We've got 1, 2, okay? We've got 1 sodium on the left. We've got 1, 2. Right, so we're going to have to double up. Put a big number in front of the whole molecule. Right, now we've got 2 oxygens, because we've got the 2 oxygens, okay? On this side we've got 1, 2, okay? We've got 2 hydrogens. On this side we've got 1, 2. Okay, balanced. There's your 3rd mark. Okay, balancing equations, good fun. Okay, here we go. 6 marker, this is worth 10%. So, sulfur is an impurity in some fossil fuels. Explain how the presence of sulfur in fossil fuels can lead to damage to the environment and how the amount of damage can be reduced. Okay, so we're thinking of sulfur in fossil fuels. Okay, so so when fuels burn, sulfur, which is an impurity in some fuels, okay, so sulfur impurities burn to make sulfur dioxide, which dissolves in rain to make acid rain. Okay, so sulfur impurities burn to make sulfur dioxide, which makes acid rain. Okay, this can corrode buildings, statues, that sort of thing, and also kill fish and damage plants. Okay, now removing sulfur from fuels can help this. Okay, removing sulfur from fuels can help reduce this. Okay, so that'll get you the 6 marks. We've mentioned plenty of good things in there. We said that it's sulfur impurities. Let me just get a red pen. There we go. Sulfur impurities burn to make sulfur dioxide, which makes acid rain. This can corrode statues and other things such as fish and plants. That's your 5 marks. If we remove the sulfur from fuels, then we can help reduce this. So just to follow this along, so sulfur is an impurity in fuels. If it burns, it reacts with oxygen to make SO2. If you combine the SO2 with water, then we'll get, just squeeze this on, H2SO4, which is sulfuric acid. So that's where we get our acid rain from. But sometimes at the filling station, the gas station, whatever, you'll see low sulfur fuel advertised. So we try and remove the sulfur from the fuel. Okay, to reduce acid rain. Okay, right, question 6. The final one. There'll be a 6 mark question on this as well. 6 mark questions worth 10%. And the first answer on question 6 is going to be D. So it says, the fuel used in this heater is a natural gas, which is mainly methane. Natural gas is a good fuel because it produces no solid waste and on complete combustion. Okay, so gas doesn't produce solid waste. Coal, wood and biomass and all that, you get ash left, don't you? That's what it means by solid waste. So there's 1 mark. How these gases could cause an increase in the temperature of the earth. Okay, complete combustion. So of fossil fuels. Well, these hydrocarbons are going to release hydrogen oxide and carbon dioxide, hydrocarbons, okay, which when those released, they go up into the atmosphere, and this causes the greenhouse effect, global warming. Never mention the ozone. Okay, ozone. It's not going to come up on any exams. It's not for C1. Okay, don't get confused. Absorb heat from the Earth, causing global warming. Okay, so those two, water and carbon dioxide, are greenhouse gases. They trap the heat in like a greenhouse. So Earth causing global warming. Okay, state an advantage of replacing fossil fuels with biofuels made from plants. Okay, so it preserves or saves natural resources. Okay, and you might just mention the natural resources, fossil fuels. Okay, so such as oil and gas. Okay, so continuing with question 6, and it looks like we're going to finish here. 12 marks for question 6. So here's 2 marks. A disadvantage of using biofuels. Right, they use land to grow them, which could be used for crops. Okay. Okay, there's less land to grow crops, so a couple of marks there. How incomplete combustion occurs and the problems it can cause. Okay, so excuse me. So we go with okay. So here we go. So incomplete combustion. Now, just to let us know what we're talking about here. So if you take a hydrocarbon like methane and you burn it, but there's not enough oxygen, instead of CO2 and water, then what we're going to get is CO, which is carbon monoxide, and that's quite poisonous. So what we need to look at is the problems by incomplete combustion. How does it happen, and what are the problems? Okay, so for example, if we had a poorly ventilated room, means not enough oxygen to burn the fuel. Okay, this produces carbon monoxide, which is poisonous because it reacts with hemoglobin. Okay, let's just see how many marks that is. So by saying a poorly ventilated room, 1 mark, which means there's not enough oxygen, 2 marks, to burn the fuel. This produces carbon monoxide, correct, which is poisonous, and we've said why it's poisonous, and that gives us a 5 marks. Knowing that the fuel needs to burn, with that, we'll give you the 6 marks. Just check the mark scheme, see if there's anything else. Yep, saying it's poisonous or toxic, we've got that. Carbon monoxide is formed, incomplete combustion. Yep, brilliant, 6 marks. Okay, good luck. Hope you did well on your mock paper. Totals out of 60, and we'll share the grade boundaries with you very soon. The idea is that we must eat, sleep, revise, repeat, and do chemistry revision with Mr. Rankin. Okay, thank you.